Hi, today we will talk about how to throw a dice using an MPC protocol. But first, let me talk a little bit about who I am. I'm a PhD student at ITU University of Copenhagen, and I work with cryptographic protocols, in particular with a type of protocol that is called MPC and stands for Secure Multi-Party Computation. But now let's try to introduce the topic of MPC in an informal way. MPC protocols try to answer the following question: how can different parties, for example, tax authorities and the hospitals and universities, combine their data to extract something that is useful while at the same time preserving the privacy? So it means that we do not want to involve any third party, but we want to allow the tax authorities, the hospitals and universities and so on to extract this information by only exchanging messages in a peer-to-peer manner. In order to give you an idea of what MPC protocols are in a more formal way, I will talk now about the Yao's millionaire problem, that is a popular MPC problem that has been introduced in 1982 by the computer scientist Andrew Yao. And it says something like that: there are two millionaires, Alice and Bob, who are interested in knowing which of them is richer without revealing to the other party their actual wealth. So from a mathematical perspective, this is equivalent to say that we want to find a way for Alice and Bob to compute the output of this function, as stated here, without requiring them to reveal their actual wealth to the other party. In the last years, many types of protocols have been developed to solve this problem, but today we will not talk about it, but we will talk about how to throw a dice using an MPC protocol. So what does it mean? We want to find a way to allow Alice and Bob to generate a random number between 1 and 6. So here is where the dice comes from, in a peer-to-peer manner without using any centralized server that has to be trusted. And we want, of course, that neither Alice nor Bob can influence the output of these dice. The protocol that is adopted is the so-called coin tossing protocol that in its original form allows two parties to generate a random bit. In this case, since we want to generate a random number between 1 and 6, we want to generate 3 bits. So as a first step, Alice generates a 3 bits random number and computes a hash-based commitment that is sent to Bob. Then Bob generates a 3 bits random number that is sent back to Alice. Finally, Alice opens the commitment to Bob, and at this point both parties have A and B, and they can compute the result D as stated here. The problem of these dice is that it's not fair, and this means that not all the possible results are equally likely, and in order to solve these we can change the way the output is computed in that way. We can use a pseudo-random number generator, and this guarantees that the obtained dice is now fair. Moreover, in this protocol, we would like to have some additional property involving the channel that is used for communication. In particular, in order to obtain integrity and authenticity, we have the chance to use digital signatures or HMAC. And that was all. From a protocol description perspective, if you would like to play a little bit with this protocol, for example, if you want to implement a monopoly without using a centralized server but in a peer-to-peer manner, you can take this code on GitHub as a building block of your game, and you can try to implement your MPC monopoly. I hope this explanation was clear enough, and to see you for the next video.